Beneath a sky that sometimes rains ash and at times hangs clear and cold, the edge of a volcano is a place of extremes. Heat rises from cracks in the earth. Winds carry mineral dust and the scent of sulfur. At the margin where molten rock meets cooler stone, life persists in small, fierce ways. This is a story not of catastrophe alone, but of living things that have learned to make a home amid heat and change. The first things to arrive where lava has cooled are often not the creatures we see with the eye. Hidden in the black rock are microbes, single-celled organisms that colonize the barest surfaces. They are the patient engineers of new land. Using chemical energy from the minerals around them, they slowly loosen rock into soil. In doing so, they begin a process that will, over years and centuries, allow larger life forms to take hold. From those microbial pioneers come the humble lichens and mosses. They cling to cracks and crevices. Their soft bodies trap dust and moisture and give shelter to tiny insects. These early colonists are tough in ways that matter here. They tolerate sudden changes in temperature. They survive long dry seasons. They can tolerate acidity that would harm less specialized plants. Where the ground warms, you will find a different cast of creatures. Insects that bask on hot stones time their movements to the pulse of the sun. Some beetles and flies exploit thermal pockets where warmth speeds their metabolism and allows rapid growth. Others lay eggs in warm substrates, so their young hatch into favorable conditions. Insects are among the most adaptable life forms at the volcano edge. They act as pollinators, scavengers, and as food for birds and other predators. Their presence marks an early step in building a functioning ecosystem. Birds can live at the very rim. Some species take advantage of the updrafts created by hot air. Raptors and scavengers use these currents to glide with little effort. Ground nesting birds find safety in sparse vegetation where predators are fewer. Many birds feed on the insects and small reptiles that inhabit the warm stones. Their movements bring seeds from distant areas and, over time, they contribute to a greater variety of plants on the slopes. Reptiles and amphibians use heat in ways that suit their physiology. Lizards warm themselves on the edge between sun and shade. Their bodies are tuned to absorb heat quickly so that they can hunt and escape predators. Some amphibians rely on cooler seeps and streams that run down from high slopes. These damp refuges are crucial during dry seasons. In their search for water and shelter, amphibians act as connectors between the hot, dry rock and the pockets of life that cling to moisture. Predators adapt to the rhythms of this landscape as well. Small carnivores may hunt along the outer slopes, picking off rats, birds, and lizards that move through the scrub. Larger predators keep their distance from active vents, but they make use of the edges where prey is abundant. Every animal here must deal not only with temperature and lack of cover, but also with occasional eruptions and the slow reshaping of the land. There are insects and spiders that are specialists of thermal habitats. Some tolerate temperatures that would kill other species. They produce proteins that protect cellular structures from heat damage. Others have behaviors that reduce risk. Burrowing deeper into cooler sand at midday, or emerging only at dusk, they reduce exposure to the hottest hours. These strategies show that survival at the volcano edge is both a matter of physiology and of timing. Plants that prosper here are not the forest trees seen lower down. They are hardy shrubs and grasses and a few trees that root in thin soil and draw water efficiently. Many have waxy leaves to reduce water loss. Others drop leaves during dry spells. Their roots reach into fissures to find moisture that collects deep in the rock. In places where vents emit warmth, some subtropical species can survive where otherwise the climate would be too cold. The volcano creates its own microclimates and life responds. At the microscopic level, the chemistry is complex. Microbes within the soil cycle sulfur, iron, and other elements that are abundant near volcanic activity. Some bacteria use sulfur as an energy source. Others metabolize iron and manganese. These cycles knit the soil together and make nutrients available to plants. Fungi form networks around roots and help in mineral uptake. Without this unseen web of cooperation, the visible community could not thrive. One of the most striking inhabitants are the extremophile microbes that live closest to vents. They form vivid mats of color in hot springs and fumaroles. Their pigments protect them from ultraviolet radiation and help them capture light. In these pools, temperatures can reach levels that would denature normal proteins. Yet these organisms have evolved thermostable enzymes and membranes that remain intact. The study of these life forms has taught us about the limits of biology and offered practical tools for medicine and industry. Life at the volcano edge also includes specialists of disturbance. Some birds nest on bare lava fields, returning as the landscape cools. Certain plants produce seeds that remain dormant until rains or cooling triggers germination. This ability to wait is a powerful adaptation. When conditions become favorable after an eruption, these dormant seeds and larvae can take advantage of a sudden vacancy with little competition. Behavior matters as much as anatomy. Animals that live here watch the land closely. They use smell, hearing, and sight to detect changes. Many species learn to recognize signs of increased geothermal activity. Ground vibrations, unusual steam, and new odors warn of approaching danger. In response, they move to safer ground. Migration is a common tactic. Some populations shift downslope or to neighboring valleys during heightened activity. This flexibility reduces mortalities and ensures that populations persist through episodes of upheaval. The volcano edge is not only a place of scarcity, it is a landscape of opportunity. Sun-warmed stones feed insects, which feed birds, which feed mammals. Nutrients from the volcano enrich soils downhill. Rivers that begin on volcanic slopes carry mineral-rich sediments to plains and estuaries where they boost productivity. In this way, the volcano, though perilous, supports life across a wider region. Human cultures have long lived in the shadow of these features. People learn to read the signals of their mountain. They cultivate fertile soils that volcanic ash makes richer. They harvest plants and animals unique to these terrains. Yet human presence comes with its own risks. Agriculture and settlement can alter drainage, increase erosion, and expose fragile communities. Balancing use and protection becomes another form of adaptation. There are also the quiet dramas of competition. Plants fight for light and soil. Predators compete for limited prey. Insects exploit niches and sometimes displace one another. These interactions shape the community gradually. Over decades, the composition of species shifts. Some become dominant for a time, only to be replaced as soil deepens and shade increases. The edge between rock and life is a moving boundary, shaped by both living processes and the slow cooling of lava. Scientific study at the volcano edge has expanded our understanding of evolution. Isolated populations can diverge rapidly. The harsh conditions accelerate natural selection, favoring traits that would be neutral elsewhere. That is one reason why islands of volcanic activity often host unique species. Their adaptations provide a living record of how life can innovate in response to stress. From a distance, the landscape may seem inhospitable. Up close, it is full of particular strategies and small victories. A beetle that times its life cycle to a warm patch of stone. A moss that traps dew and creates a microhabitat for mites. A bird that builds a nest on an exposed ledge because predators rarely venture there. These are modest adaptations. Together, they make an ecosystem that is resilient in a particular way. Near the end of our account, it helps to reflect on scale. The volcano shapes climate and soils and rivers on a scale measured in kilometers and centuries. Yet the survival of a single species here depends on a momentary choice, a mutation, an early hatchling that reaches maturity. Both scales matter. The slow, geological power that creates new land and the nimble biological responses that claim it are two sides of the same story. At times, the volcano will roar again. New lava will flow and new ash will fall. To watch these processes is to see the balance between destruction and renewal. The creatures at the edge do not simply endure for their own sake. They are participants in a cycle that renews habitats and reshuffles life. Their adaptations, refined by generations, allow them to inherit land that has been remade. Scientists who study these margins often return with two impressions. First, that patient observation reveals patterns no single visit can show. Teams take careful measures of temperature and chemistry. They map where plants appear after a cooling season and where animals shift their ranges. Second, the insights are not merely academic. Thermostable enzymes from heat-loving microbes are used in industry. Plant traits that conserve water inform crop breeding for dry regions. Lessons learned here help people facing change elsewhere on the planet. That practical value does not lessen the wonder. It raises a responsibility to protect fragile springs and seep lines and to avoid trampling the thin soils that sustain pioneers. Small acts of care allow natural recovery to unfold. By preserving microrefuges and limiting needless disturbance, we give time for life to reclaim cooled flows and to build richer soils. Our choices now will affect whether distant descendants will see these edges alive with the same strange and careful beauty. May curiosity guide our hands and humility shape our decisions. We leave this place with a view that is neither triumphant nor mournful. It is a view of persistence and of respect for complexity. A world where life finds a foothold in heat, where cooperation among invisible organisms makes room for visible ones, and where the movements of the earth themselves set the terms for survival. In that meeting between fire and living flesh, there is a lesson about the limits and the resourcefulness of life. In the hush that follows dusk, when steam rises from warm stones and stars appear above ridgelines, the edge of the volcano keeps its quiet work. A beetle crosses a cooled flow. A moss clings to a crack. A bird checks its nest and settles. These small acts add up over time. They remind us that even in the most challenging places, the world is always making room for life.